A little bit more difficult here, but you guys can do this, I promise. All right, so you look at this identifying zeros in their multiplicities page. Make sure you're all coming back here. I know some of you I sent to the exit ticket. Make sure you come back to me, please. Excellent. So if you look at this function in blue on my screen, let's write down the intercepts. Edgar, could you please give me one intercept? X equals, what do you got for me? Excellent. I like that you started with that one. Who's got the next one for us? Let's go with Kayla. -1. And the last one for us, let's go with Aiden. The last x-intercept.
-1.
No, we said -1. Kayla said -1. It is, but give me the last one. +2. Thanks to Aiden. Okay, so when you look at this, that's 3 numbers. But when I look up here, I have x to the first power, x squared, x cubed. That is what? 6. 1 plus 2 is 3. 3 plus 3 is 6. So why do I not have 6 roots? Because -1 and +2 have multiplicity. Okay? That means they're going to be double or triple roots. So if you take a look at -3, let's all look at -3 together. Do you see -3? Do you see how that crosses the x-axis normally? So that is what we call a single root. It's single. Okay? Now, take a look at -1. Do you see -1? How it crosses the axis? Do you see how it has that kind of inflection point where it almost becomes horizontal before it goes back up? Do you know what that's reminiscent of? That's reminiscent of the cubic function. And you'll notice that it comes from x plus 1 cubed. So this is called a triple root. That's called a triple root. So whenever it crosses, but it does that little kind of inflection as it crosses, that's called a triple root.
How do you know all of these?
No, yes, today I am, but in the past I have studied it. Yes.
I'm just saying it's like
I read about it, yeah.
like so it's easy.
Yeah. Well, I want to be prepared when I teach you. Okay.
I just thought this is
No, I just roll out of bed and just boop. No, I'm not that gifted. I have to work hard at it. All right? You might know people that just like wake up and they know things. That's not me. All right? I'm like, what time is it? Okay, so let's do the last root. The last root is x equals 2. Do you see how it touches and then comes back? It does not cross the x-axis. Now you'll notice we have a single root and a triple root. That's 1 plus 3, which is 4. So that leaves me with a double root, which gives me 6. All right, so what I'm trying to teach you is that whenever it crosses the x-axis, it's going to be an odd numbered root. Normally, in your last algebra class, they look like this, normally crossing through -3, single root, not a big deal. Now I'm showing you where it crosses, but it has kind of an inflection, like the cubic function, that's a triple root. Here, whenever it hits, touches, and doesn't cross, it comes back. That's going to be an even numbered root, and for our purposes, most likely will be a double root to get 6. Any questions on how we got to 6? Now, I need you to know this information to help us write the equation for these functions. That's the hardest part of today. So let's show you one more thing before we try. Have you guys heard about end behavior for functions? All right, so basically when you think about this, let's first start with the odd degrees. So odd degrees would be cubic to the 5th power, to the 7th power, things like that. So if it's an odd degree, they're going to go in opposite directions. All right, so that's why if you think about x cubed, when we draw x cubed, it goes like this. Do you see how 1 is going up and 1 is going down? So that's whenever you have an odd numbered degree, it should be opposite. All right, so if you look at even numbers, even degree, like x squared, here's x squared, they're both going in the same direction. Okay? Now, the only way you can change how these look in terms of, bless you, vertical reflections is to throw a negative in front. So if there's a negative in front, what's going to happen to these arrows? It's going to flip. This one will go up here, that one will go down here. So negative x cubed looks like this. All right? And you guys already know what happens with negative x squared. It just opens down. All right? Let's see if we can try one together. All right. Let's see. I want you to think first. What degree is this function going to have? What degree? Right now, I don't need a number. I need even or odd. Jalen, what do you think? Why do you say odd? Wait, what is it, Jalen? It's even. How did you know it was even? What did your brain see all of a sudden? They're going in, you know it, one direction. Okay? So if they're both going in the same direction, you know it must be even. Now, do I know if that's squared to the 4th power, to the 6th power yet? No, I don't. Let's start counting. What do we have here? We have 1, 2, 3. But wait, Jalen, you told me an even number. How come I just counted an odd number? Oh, 1, 2, 3. Very good, Jalissa. 4. So actually, this is going to be a degree of 4 because a bunch you've already noticed, this point right there is called a double root. All right. So let's see if you can write this down with me. F of x equals, whenever you go backwards to write the function, you always want to think opposite. So what is this root right here? What's the x value here? -3. So when I write it, I'm going to write x plus 3. Because you're asking yourself, what number makes x plus 3 0? -3. So always think opposite. Are we good with that? All right. What about this root? It's at what? 2. So I'm going to write x, not squared yet, x minus 2. Now, Jalissa, squared, because it's a double root. All right, that squared means it's a double root. Times, what about this last one? Where's this last root? That 5, so x minus 5. And confirm again that you have 4. 1, 2, 3, 4. Now, the only thing we have to do is we're going to put this letter A in front. That letter A is going to be our constant that's going to tell us exactly what the equation is. All right, and here's how you're going to do it. I always tell students to pick any point they want. So you can pick any point you want on the graph. But I think the easiest one, the one I'm going to show you, is to pick the y-intercept. Does everybody see the y-intercept? It's right here. What's that point? 0, -2. All right? So what am I going to put into all of these x values? 0. Very good. So I'm going to write 0 plus 3 times 0 minus 2. Don't forget the square times 0 minus 5 times A. What's going to replace f of x? Now 0 is the x. What's going to replace f of x? -2, because remember, the f of x is just a fancy way of saying y. Now, guys, this is the heart of algebra. You have an equation with one unknown, the letter A. So write down letter A. What is 0 plus 3? 3. What is 0 minus 2? -2, and then Jalissa's brain squared it. Yes, so she said 4. We all agree? And then 0 minus 5? -5. And then bring down the -2. Okay, if you need a calculator, you can, but I think we can do 3 times 4 times 5. -60. So we have -60 times A equals negative 2. So if I solve for a, what am I going to do to both sides? Divide by negative 60. And you'll notice a negative divided by a negative will give me a positive. And how are both of my arrows going? They're going which direction? Up, so that a better be positive. That's another check you can make if you mess up at the end. So what's 2 over 60 as a fraction? 1 over 30. So here's my answer. My answer is f of x equals 1 over 30 times x plus 3 times x minus 2 squared times x minus 5. Beautiful. Fantastic job. I love these problems. There's so much going on, so much learning, so much algebra, so many things you got to know that you could trip you up. It's amazing. Suzanne.
So you put minus 2 and minus 5 because from 0 it's shifting to 0, right?
You can think of it that way. I always think, how did I get a root of 0? What value is going to make x minus 2, 0 a positive? So whenever you write root form is what this is, you always want to think opposite. It's always x minus your root. X minus your root. So here, the root was negative 3. What's x minus negative 3? X plus 3. Okay? This is really challenging. So I'm going to give you guys about 10 to 15 minutes to try number 3 and number 4. In number 3, it's just about the multiplicities. So this is where you're going to write down your x values, right? Your roots. Let's see, we have 1, 2, 3. Ooh, do I have 4? I only have 3, but they're going to have some multiplicity, right? So I want you to write that down. You'll do that. And then the hardest question, the really challenging question is number 4. Can you write the equation for this? If you can do this, you have had a very successful day. I'm going to give you the rest of class. All right, but at about 9:20, 9:22, in about 10 minutes, I'm going to say sit down in your seat and shift to the exit ticket. All right, go!